Okay, let's discuss about the library Matplotlib. Matplotlib is nothing but it is a low-level graph plotting library in Python that serves as visualization utility. We can visualize the data whatever we have taken. Okay. So Matplotlib was created by John D. Hunter and it is a open source. We can freely use it. Okay, let's see what are the few segments are written in C, Objective-C and JavaScript for platform compatibility. So Pyplot. What is Pyplot? It is nothing but it is a Matplotlib. It lies under the Pyplot submodule. Means Matplotlib is a utility. It is a library, but in that submodule is Pyplot. Okay, it is usually imported under the PLT. We can take as PLT plot alias. Okay, so what I am doing, I am importing Matplotlib.pyplot as PLT. So first of all, what we need to do, we need to install pip install Matplot. We need to install Matplotlib. Then what we need to do? So we are importing Matplotlib.pyplot as PLT. We are taking plotting as PLT, that is alias as PLT. Now what I am doing, draw a line in a diagram from position 0 to 0 to the position 6, 250. Okay, this is the position what I need to do. I need to draw a diagram. Okay, so what I am doing, I am importing NumPy as NP because we are working on arrays, right? So NumPy is used for creating arrays, right? So this is an array 0 to 6 and another array 0 to 250. So we are taking x points is equal to np.array 0 to 6 and y points is equal to np.array 0 to 250, right? So 0 to 6 x axis, y axis 0 to 250. So what we need to do, we need to plot x points and y points. Okay, plt.plot x points comma y points. What we need to do, we need to plot.show. So what will happen, this is the thing which will happen. So till 250 at the position 0 to 0 and the from position in x-axis 6. So at 6 to 250, right? 0 to 0, 6 to 250. So this is called plotting. We can also excuse me. We can also use by different plotting methods like what I am doing here. Plot x comma y. Plotting x comma y points. The plot function is used to draw points markers in a diagram. Okay, by default the plot function draws a line from point to point. From point to point we can draw the line, right? The function takes parameters for specifying points in the diagram. So for parameter 1 is an array containing the points on the x-axis. That means we are accessing this 1 in the x-axis and the parameter 2, whatever we have taken in parameter 2, that will be taken as y-axis, right? So this is the explanation of the program. So if we need to plot a line from 1 to 3 to 8 to 10, we have to first two arrays, that is 1 comma 8 and 3 comma 10 to plot the function. So this is what we need to take. So what I am doing, we need to draw a line in the diagram from the position 1 comma 3 to position 8 to 10. So import Matplotlib.pyplot as PLT, import NumPy as NP. So x points is equal to np.array 1 to 8 and y points is equal to np.array 3 to 10. So what we are doing, we need to plot.plt.plot x points comma y points. Now we need to show the plot plt.show. This is the thing which happened. So at the position 1 comma 3, so at the axis 8 to 10, right? See 8 to 10, 1 comma 3. This is what will happen. So at the first position to at the 8th position x-axis and at the 3rd position to at 10th position in y-axis. This is what we have. We can also plot without line. Okay, we can by using some of the markers like 0. This is the marker which I had used in here. So plotting without line. We can also plot without line with the notation parameter this, which means rings. We can plot with by using the rings. How it will get the output. See. So just like circles, we'll get like not the line but just circles, right? See here 1, 2, 3 circle and the same 8 to 10 circle, right? At the position of this is the x-axis and this is the y-axis. Position 3 to 1 and at the position 8 to 10, right? We are just placing a circles. So multiple points. We can also draw a multiple points. We can take many of the points like this. So I am taking 1, 2, 6, 8 arrays in x-axis and 3, 8, 10, 1, 10. Means at the position of first, whatever in all these parameters, whatever in the first position 1, 2, 6, 8 all will be taken as x-axis, 3, 8, 1, 10 all will be taken in y-axis. So we need to show this plot. See, this is the plot how we will get. Default x points If we do not specify the points on the x-axis, they will get default values. It will be taken as 0, 1, 2 depending on the length of the array we have taken. So if you want to leave the same example as above and leave out the x points, and we can draw like this. See, I'm only taking the y points. Okay, I'm not taking the x points. We can also draw like this. What will happen? It will get like this. So it will consider from 0, 1 like this. It takes as 0, 1, 2, 3 default from the based on the length of the arrays which we have taken in y-axis. So what are markers? Markers are nothing but it is a key argument marker to emphasize each point with a specified marker. We can mark with specified marker. So what I am taking here, marker I am taking, what is the marker I am taking? I am taking circle. Okay, we can also get the circles like this, circles. At each point we will get the circles. We can also use the stars. So I am using here stars, right? So I am using here stars, right? These are the stars, right? So we can also have circle, star, point, pixel. We can also take the pixel. For pixel, we can use a comma and x for x, x filled plus, square, like this. Okay. If you need to get plus filled like this, p, we will be taken like this. Okay. These are the marker descriptions. SV, if we have taken S at the particular place, we will get square. Diamond thin. If you want to get the diamond thin, we can get also pentagon. We can also get hexagon. By using the capital H, we will get hexagon. But by using small also, we will get hexagon. If you are using a V, that will be a triangle down. If you are using cap, that is nothing but it is a triangle up. If you are using a left, means a less than symbol, then it is a triangle left. If you are using a greater than, that is triangle right. And we also try down, try up, try left, try up, try right, that is 1, 2, 3. We can take like this. V line is nothing but we can take a straight slash. Okay, we also take the H line, that is horizontal, vertical and horizontal lines. You can also take like this. These are all the markers. So if you want to mark it specific place, okay, at this position we need to change. Okay, please try all these example by using this. At this position you can use S. Okay, what is S? What is S? S, I believe that it is a square, right? S is a square. You can also check like that. So we have got here squares, right? We can use triangle. If you want to use a triangle, what is the description here? What is the symbol? Well, if you want to use a diamond, capital D, we can use here capital D, right? Okay, it will get in dimension. So here diamond, right? If you want to take the hexagonal, then what we will do? We will take H, right? If we have taken H, what we will get? We will get hexagonal. This is the hexagonal symbol. You can see the difference, right? If you want to take the V, capital V, that is triangle down. We will get triangle down. See, we will get triangle down. What we will get? We will get triangle. So this is how all these happen. And we can also format strings FMD. We can also use the shortcut string notation parameter to specify the marker, that is marker line color. We can also use the color also. R is nothing but red. The circle should be in red, like that. So see, the circles, whatever the circle points we have taken, that should be in red color. Okay, these are the different types of solid line. If you want to draw it, solid line, dotted line, dashed line, dashed dotted line. For everything we will get this. Okay, so this is for that. So the marker, the different line references, we can also have different colors. If you have taken R, that is taken as red. Okay, if you have taken G, that is taken as green. If you have taken B, blue. C for cyan, M for magenta, Y for yellow, K for black, W for white. Okay, if we have used here at the position, this if I had used what we will get? We will get triangle, right? If I had used H, hexagonal, we will get hexagonal, and I am marked marker face space. What I am taking? I am taking 20. So see, what is H? Hexagonal. If I had taken here a circle, that is O, what we will get? We will get circle, right? In circle. The size I had taken is 20. If we have taken 50, what we will get? We will get the size somewhat big, right? If we have taken 10, we will get somewhat small size. This is the difference, right? You can check. Okay. This is the difference. If I had taken 5, okay, I had taken the size 5 and I am taking here hexagon that before we have taken. Okay, so this is the hexagonal symbol, and if it is not looking properly, you can take third. Okay, so that we can look big. See, this is the hexagon. So we can use whatever the markers we have, we can use that and we can change. So here what I am doing, marker face color. I am giving the color red and I am taking the circle and I am giving the size 20. So let's check. See, so at marker at end of the place we need to get red color, and I am taking a blue color, and here what happened, I had taken circles. So we can also change to hexagonal, right? We can also change to hexagonal and we can also change to green color. Final G. See, this is the at the end we have green color. It is not looking properly, then we can give me a size 30 so that it will be very much clear. See, here it becomes green. We can also use yellow color, Y for yellow, right? We will be getting yellow color. We can also use cyan, C for cyan. We can also use that, right? Cyan. Okay, this is what we will happen with colors. So we will take red so that it will clear somewhat clear. See, red color. Okay, so here what I had taken here, I had taken red color, same thing. Okay, I need to plot this. What will happen? We will get like this. So if you have used an MFC, so this is what here saying. If you have taken MFC to set the color inside the edge of the markers, we can see we can take a marker face color. Okay, the shorter MFC to set the color inside. So I need to set the color inside. So I had taken MFC is equal to R, right? MFC is nothing but just borders, just sides, right? Here I had taken MFC. That means inside the color. I need to. So if I had given here hexagonal, what I will get? I'll get hexagonal symbol. Okay. So this is what the difference. I had given the border red and I had given both these red. Then what I will get, both the borders and that will be getting in red color with circle. Okay. We can also give different types of colors, like we can give the code also. Okay, if you want to look somewhat effectually. See, this is the output. What we have get. So this is the output. This is our output. So again, I had taken hot pink color. MEC is equal to hot pink. The array is same thing, but what I am taking hot pink. So what I need to get? Hot pink color. That is pink color. So then what is dotted? Dotted is nothing but if you want to get the line style dotted, then you will get the lines with dotted. Okay. And with dash, if you want to get the lines with dashed, we will get the dashed lines, right? These are the dashed lines, like that only. So we can also use the dot and dashed lines like this, and we can also give the color, right? We can also give the color. This is the red color. Line width, we can also give the width. But if you have given the line width, what will happen? It will see, it will show dark. If I had given here 10 lines, it will reduce to somewhat size, right? Okay, this is somewhat size. If I had given to show somewhat 15, then it will show like this. So much long. Like this, it will happen. That is called line width. Okay. We can also plot with two arrays. I am taking here two types of arrays. Okay, what will happen? We'll get the two types of arrays. Okay. Here arrays, I had taken arrays, average, pulse and calorie. I am giving the labels, means side. In x-axis, I need to get average pulse, and in y label, I need to get calorie burnage. So here it will take like this. Calorie burnage at y-axis and average pulse at y-axis. Okay. So I need to add a plot title. If you want to add a title, we can also add title and labels for x and y axis. So here I am adding the title sports watch data. We are working on sports watch data. So what we need to do, we need to find the average pulse at x axis and we are creating the labels at our x and y axis. Okay, so what we are doing, we can check this. So sports watch data, this is the title, this is the y axis, and this is the average pulse is the right axis, right? We can also set font properties for titles and labels. How can we change? See, here I am giving the font to font 1, font to font 2. Okay, so for title it should look somewhat in a different font, and for x and y axis labels it should get in different font. Then we will use like this. Okay, font 1 family is equal to serif. So I am taking serif. The color is blue and the size is 20. If I had changed it to 30, then it will look somewhat big, right? It looks somewhat big. We can also change the size. We can also change the color. We can also take the family. We can also take here like a Calibri. C-A-L-I-B-I-R. Okay, Calibri. Okay, we can also take the Calibri font. Okay, that is what we have taken here. So we can also position. We can also, if you want to give the position like in center, we can also give in center. We can also change that. Okay. See here what I am location and what I should locate at left side. So I am giving at left side. So see left side. If I had given here right, it will show us right side. See, it will come at right side. If we have taken it left side, it will get it the location will get it left side, right? Okay, so we can also add the grid lines to a plot. How can we add a grid lines to a plot? See, with Pyplot, you can see the grid function. We will use the grid function to add grid lines to the plot. So what I am doing here, I am importing NumPy as NP. So we are for every plot here for plottings we are using only arrays, right? We are solving on arrays. So what I am doing, I am taking the arrays import NumPy as NP, import matplotlib.pyplot as plt, alias I had taken alias for matplotlib.pyplot as plt. So I am taking x and y axis. So in x axis I am taking some of the arrays is equal to np.array. I am taking some of the values like 80, 85, 90, 95, 100, 105, 110, 115, 120, 125. So in y values I am also taking a np.array, some of the arrays like 240, 250, 260, 270, 280, 290, 300, 310, 320, 330. So what I need to know, what I need to plot, I need to give the title, I need to give the x label, I need to give the y label. Okay. So I need to plot x and y, and I need to, what is the method I am using here? Grid method, plot.grid. Okay. And what I need to do after gridding, I need to show them. Okay. I need to show the visualization. So this is what I had given. So this is the grid method. Grid method is nothing but it will shows in boxes, grids, right? This is the grid method. The sports watch data. We had successfully given the title, and we also given the labels: calorie burnage and average pulse, right? Average pulse. Okay. We can also specify which grid line to display at what position it specifies the line. Okay. Legal values are x, y, and both. We can take both. Default values both, right? So what we are doing here is, so I am importing NumPy as NP and importing matplotlib.pyplot as plt. X is equal to what I am taking. I am taking np.array is equal to, I am taking some of the values, and in y also, in y axis also I am taking some of the values. I am giving the title sports watch data, and in x label I am giving average pulse, in y label I am giving calorie burnage. Okay. Now what I am doing, I am plotting, and then plt.grade axis I am giving a x axis. Excuse me. We can also give the grid axis is equal to x. Now I need to plot show. Let's. So only at x axis we have. If I didn't given any of the axis, then what we will do? It will take x and y as default. That's what we have studied on the theory on the upper side. So here I am giving y axis. That means we will get at y axis. If I didn't mention any of these axis, what I will get? I will get both the grid in x and y axis. So if I mention only y axis, I will get the grid in y axis. If I had mentioned only in x axis, I will get it x axis. If I didn't mention anything, then what I will get? I will get in both. It will get default. Okay, set line properties for the grid. We can also set up line properties for a grid like color, style, line style, how much the line width should be. We can also give it. See what I am doing. I am giving the color is equal to green. Okay, and I am giving the line style. What is the line style should be? It should be dash. Okay, whether it should be dotted or whether it should be dash. And I am giving the line width is equal to 0.5. Now I need to show. So this is the line style and this is the line width. If I had given 5, only 5, what will get? This is the line. What is the color here? Color is green color. So this is the green color. That should be in line style should be a grid line style should be what? Dash, right? So if I had mentioned 0.5, we will get low. So this is it, small dots, right? It's looking like dots. That's why I had shown you clearly by giving the big value. See, by giving the big value, we can clearly see that this is a dashed line style. Okay, we had given the green color with a line style that is dashed with the width of 5. We can also give 0.8. Okay. So display multiple plots. We can also display multiple plots. Like I had taken x values, y values, 2 plots. I had designed 2 plots. Okay, where we can subplots that. How we will get like see we will get 2 plots like this. We can also create 3 plots also. Like for example. So if we have mentioned like this plot thing, then it will be not disturbed. It will look straight. Okay. So I need to change your values. 23, 40, 70 and 50. I'm taking some of the like these values. So I need to subplot like 1 comma 1 comma 2. Okay, this is my plotting style and I need to show that. Okay, I need to plot that and I need to show next. What we will get? Okay, 1 comma 1 comma 2 is not taken. Let's take this one. Okay. Okay, see, let's check this. We will getting in this only we will getting another plot, right? This is the way how we can take the different type of plots. Okay. So what is the subplot function? Subplot function is nothing but it can take 3 arguments. So this is we also take 3 arguments. We can also take 2 arguments. We can also take 1 argument, right? So in this I had taken 2 plots again. So these are the 2 plots which I had taken. So these are the values how it has gone. So we can check another example. So we can take multiple like arrays also, multiple arrays also for plotting. So what I am doing, I am importing Matplotlib as a .plt, pyplot as plt and importing numpy as np. So I had plotted 1, I had plotted 2. Okay. I am taking some of the arrays in first plot, in second plot, in third plot also. Like I had taken multiple plots. Okay. I had created subplots like this. I had created many of the plottings and then what I had told, I had plot x comma y and I told to show. Okay, this is what this is also the way how we can plot any number of the plottings. Okay. So here I am taking another example that is I need the title says, I need the title of income. So for everything I had given different types of one is sales, one is income. Okay, so I need to show in different types. We can also create labels here. Number of times spent on sales, number of income, like means we can also give the names for x comma y labels. So, okay. So we can also give the super title also. like subtitle and supertitle. Okay. See here, I am giving the subtitle, that is supertitle is my shop. In my shop, I am having the sales and I am having income. This is what I am having. See, this is my shop. This is the supertitle. This is the subtitle of both the x comma y comma axis of a different arrays. So we can also create the scatter plots. With pyplot, you can use the scatter function to draw the scatter plots. You can also draw the different types of scatter plots. Okay, the scatter plot function plots one dot for each observation, right? Okay, we can also take the same length for one of the values of the x-axis and one of the values of y-axis. So what I had done, I had imported matplotlib.pyplot as plt, import numpy as np. So I am taking x-axis sum of the arrays and in y-axis sum of the arrays. Now what I am doing, I am plotting scatter. Okay, we can scatter plot, we can histoplot, we can pyplot, we can plot at different types of plots. Okay, we are having different types, right? So what it will happen? It will, a scatter plot is nothing but it shows in small rounds like circuits. This is called scatter plot. So if the observation in the above example is the result of 13 cars passing by. See, this is the observation of 13 cars passing by x and y axis. We have taken that example. So in the x-axis shows how old the car is. It shows how old the car is, and the y-axis shows how the speed of the car when it passes. When it passes, what is the speed of the car? Okay. Are there any relationship between the observation? Is there any relationship between the key observation? See, it seems that there is a newer the car, the faster it drives, but that could be a coincidence. After all, we only registered 13 cars. Okay, we didn't. If you have the large term of data, then we can analyze. Okay, we are having the short term, and it is the newer car. It is faster the drives. Okay, but it will having the sum of the coincidence. If we are taking the two types of the 13 car speed and 15 car speed, let's see. So I need the scatter plot for both the arrays, x and y axis, and for both the arrays. What I am getting? I am getting, see, there will be a it is getting the both are having the same conclusion, that it having the same points. It means by comparing the two plots, what we can think, I think it is safe to say that they both gives us the same conclusion, because the newer the car, the faster it drives. If we are having the newer, then it fast drives, right? That is the conclusion. What is colors? Color, we can also set different types of colors for scatter plots also. What we are doing here I am giving the color hot pink. Okay, I am giving what I am giving. I am taking the importing Matplotlib as plt, import numpy as np. So here what I am taking some of the arrays in x-axis, some of the arrays in y-axis. Now I need to plot. What is the method I am using here? Scatter method, right? Scatter plot. I need to get in scatter plot. So x comma y, and I am giving, what is the color I am giving? I am giving hot pink for first axis, and for second I am giving some of the code. Okay, I am giving some code. So I need to print it. So this is the hot pink. This is the first color for first array, and this is the whatever we have taken the code hash #8C999. This is the color. Okay. These. So color each dot. You can even set a specific color for each dot by using an array of colors as value for the C argument. What we can do, we can take any number of the colors. Like for every array, for 5 we need to get red, for 7 we need to get green, for 8 and 87 we need to get blue color. Like that. We had given how many arrays are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total we have taken the arrays, that is 30. So we need to take the 13 colors. So each color, whatever the position, at 0th position there is 5 value, right? At 0th position there is a red color. So for 5 and for 99 we will get red color. For 7 and 86 we will get green color. For 8 and 87 we will get blue color. For 7 and 88 we will get yellow color, like that. Okay, each color it will define. So what we will get? We will get different types of the colors, right? So what is color map? It is nothing but the Matplotlib module has a number of available color maps. So we can take from the different types of colors, right? So the color map is called as viridges, VIRIDIS, viridges, As you can see, it ranges from 0, which is purple color, first purple color, up to 100, which is yellow color. So there is a virtuous color. We can Google it and look. First it will start from, it ranges from purple color to last it will get to yellow color. Okay. So in addition, you can also give the values on each of every point in the scatter plot. So I am taking two different types of arrays and I am giving the values 0, 10, 20. We can also give the values up to 100. At 100 position, what is the color? It is yellow color. At 0 position, we have purple color. In middle, there will be somewhat variance, different of the color. Okay, see what will happen. So it is showing different type of colors like this. Okay, so we can include the color map in drawing by including plt.colorbar. We can also use like this. Okay, so what is the color map? That is variations. Okay, so this is the color map. So we are getting at a position 40 we will get this color, and at position of 0 we will get purple, and at the position of 100 we will be getting yellow color. So we can also call the C map, color map. Okay. Okay, let's start from the size. We have stopped at size, right? Okay, we can also end the size by using the S argument, just like colors. Make sure that the arrays for size have the same length as the arrays of the X and Y axis. We should have the same size of the X and Y axis. So what we are doing here, importing matplotlib.pyplot as plt, import numpy as np, and x is equal to np.array. I am taking some of the arrays in x axis, I am taking some of the arrays in y axis. So I am giving the sizes is equal to np.array. I am giving the sizes for different sizes like 20, 50, 100, 200, 500, 1000, 60, 90, 10, 300, 600, 800, and 75. For each position it takes, for 0th position it will take like for 599 it takes 20 size, for 786 it takes 50 size, like that it will take the sizes. What we need to do, we need to plot scatter. Okay, plt dot, what we are doing scatter plot x comma for which, x comma for x comma y axis, right? X comma y axis, and we are giving the sizes is equal to sizes. So I need to show the plot. What we will get, we are giving the slices. We are somewhere we had given 500 size, somewhere we had given 1000, like that we had given different sizes. See the different sizes. We had given 20, this is the size of 10, this is the size of 20, and different we had given for different sizes. Okay, this is what happened in Matplotlib if we have mentioned the sizes. So what is alpha? Alpha is nothing but it is just a transparency. It shows the transparency of the dots with the alpha argument. Just like the colors, what we have done, we need the same sizes, the same length of the arrays of x-axis and same length of the arrays of y-axis. For example, see for example what we have taken here, import matplotlib.pyplot as plt. We are importing and what we are importing numpy as np. So I am taking some of the arrays in x-axis, I am taking some of the axis in y-axis. So size is equal to np.array. So I am giving the sizes, and for the sizes what I am doing, I am giving the alpha, that is for transparency. I am giving the transparency of 0.5. Okay, I need to show the, see, I had given the transparency, so it is showing like that, somewhat transparent. How much we had given? We had given 0.5. Okay, it shows some more transparency. Okay, we had given 0.1 transparency, so it shows similar transparency. It shows like this ones. If we had given 0.5, it will show somewhat like this. Okay, some dark. Okay, this is about the transparency. If you had given 0, it doesn't show it like bubbles. It shows like bubbles. See, bubbles. But it will not visible to us. If we had taken at least 0.1, then we will get. See, so this is called transparency. So we can also what we can do, we can for colors random, third random, we have seen the random. In random we had seen different types of colors, random and right? So on that also we can do. See what we are doing, we are importing matplotlib.pyplot as plt and import numpy as np, right? So what we are doing, x is equal to np.random. So I am giving the size. So 100 till 100 I need to get the values, and for y also I am giving the same size. For colors also I am giving the same. And what I need to do, I need to get sizes is equal to 10 star np.random dot random. I am giving the sizes. So what I need to give. So s is equal to sizes, we are defined s is equal to sizes, x comma y, c is equal to nothing but it is colors, and alpha is equal to what I am giving. I am giving 0.5% transparency. I am giving the colors, he map, color map, NIPY spectrum. Okay. So what we need to do, we need to show the color bar also. Okay. Need to show the color bar also. PLT dot color bar and then PLT dot show. Right. This is what we are asking for. So what we will get, see, with the different colors. So NY spectral, we had given alpha 0.5 and we had given different types of colors, and we had mentioned random. That's why we are getting these many colors. Okay. So we are giving the size of 100. So we will get the 100 values. If you know 0.0 like that, there will be a many of the values, right? So we will get like this. We can also create the different types of bar charts. Okay. For creating bar charts, we will use the bar function, right? Bar, with pyplot, what we can use, we will use bar function to draw bar graphs. So what I am taking some of the characters like A, B, C, D in x-axis, and some of integers like 3, 8, 1, 10. Okay. Now what I need to get, I need to get the plotting. I need to get the plotting of bar. Okay. We can get the bar plots. So this is the bar. This is the bar plotting. So what I had shown, at A, I need to get 3. It is exactly nearer to 3. And at B, I need to get 8. It is nearer to 8, right? At C position, I need to get 1. Okay, 1. Okay, at D position, what I need to get 10, right? So this is the values of x comma y. Okay. We can also see the bar function takes argument that describes the layout of the bars. Okay, it describes the layout of the bars. The categories and the values represent the first and the second argument as it is, same like as it is. So now what I am doing, I am importing SYS. Okay, and this what I am importing. I am importing Matplotlib. Matplotlib dot use arguments. I am using arguments, and then what I am doing, I am importing Matplotlib dot pyplot as PLT and numpy. I am taking the numpy as NP. So I am taking some of the apples and bananas. And I mean y, I am taking some of the values like 400 and 350. Now what I need to get, I need to plot bar. Okay, I need to show that. Okay, see next. Okay, this is the plot. This is the apples and this is the bananas. Okay, this is what we need to get. Okay, this is apples and bananas at 400 at 350, right? At nearly exactly 320, 350. And what I am doing, just again I am importing Matplotlib pyplot as PLT, import numpy as NP. I am taking different types of values, say in the x-axis like A, B, C, D, characters, different characters. In y also I am taking np.array 3, 8, 1, 10. So what I need to do, I am going to plot bar x, y that shows the bar. It is used to set the colors, different types of color. It means it shows vertical like this. Okay, it's nothing but it shows the horizontal. Okay, horizontal. So what we have here using here, it is using BARH. If you had using bar, what will get? We'll get like this. Here I had used bar should be in horizontal. So it has gone to horizontal. Okay, clear? So let's see bar color. The bar and bar take the key argument color to set the color of the bars. We can also set the colors. Okay, here I am setting the color red, right? So what we will get? We will get the red color. What I am doing, I am importing Matplotlib.pyplot as PLT and importing numpy as NP. And in x-axis, I am taking the characters A, B, C, D. And in y, I am taking some of the values like 3, 8, 1, 10. Now I need to plot plt.bar bar x, y, and I need color. Color is equal to red. I need to show the color red. Okay, I need to plot show plt.show. It was in red color. if I had used H, what will happen? It will show the horizontal, right? So this is what what happened. So next another example, I'm changing same for same values. I'm just changing the color, that is hot pink. Okay. So what we will be getting? What we will get? We will get see hot pink color. We will get the pink color, right? And we can also give some of the code, right? We can also give the color code, that is #4CAF550. I'm taking some of the color code, and I had assigned the values, different types of the values. That is the color code is nothing but it shows the parent group, right? So we can also give the width. So how the width should be, how the height should be, what is the height, what is the width. We can also give the width. So what I am doing, same as we are working on the arrays, complete arrays. That's why we are taking NumPy, right? And we are using for visualization, so we are taking Matplotlib, right? That is what we are taking. This is very easy concept. So this is the width. The width should be 0.1. Okay, the distance, right? This is one type. There will be a different properties to discuss. Okay, again what we are doing, we are discussing about height. We can also give the different type of height, but with what we have used in horizontal. Okay, here using here horizontal. So see what I am doing, I am importing matplotlib.pyplot as plt and importing numpy as np, right? X is equal to, I am taking np.array a, b, c, comma, d. Y is equal to np.array 3, 8, 1, 10. I have taken these values. So I am plotting for horizontal bar bar h x comma y, and to get x comma y axis, and what I am doing, I am giving the height 0.1. So this is the height. This is how we will show the output. And what is histogram? Histogram is nothing but it shows the frequency distribution. So histogram is a graph that is showing frequency distribution. It is a graph showing the number of observation within each given interval. What it will shows? It shows the graph with number of observations within given interval, right? For example, we are taking the height of 250 people, and you might end with a histogram. You can also end with histogram. How we will create a histogram? In Matplotlib, what we will do, we will use the HIST, okay, that function. HIST function is used to create the histogram. The HIST function will use an array of numbers. What we will do, it is used to create a histogram. The array is sent into a function as an argument. We can also pass it as an argument. For simplicity, we use NumPy to randomly generate an array with 250 values. Okay, if you want to generate with the array with 250 values, what we will do? We will use the random method, that is a random.norm, right? Where the values will concentrate around 170, and the standard deviation. What will get the standard deviation? The standard deviation will be 10, right? So this is the way how we will create the histogram. Let's see the example. What I am doing, I am importing the NumPy as entry, and for that I am taking x is equal to np.random.normal with standard deviation of 10 with the with concentrate value of 172. How many values? Still 250 values, right? This is what we have taken. Then what I need to do? I need to print x. Okay, these are the values which lies between 170 to 250, right? So what we have done, again we have done that only. Now what I need to plot, I am plotting plot.hist of x. Okay, I need to plot histograms. I need to plot histograms. So this is the histogram. This is how we will get the histogram visualization. So we can also create the different types of pie charts also. Okay, we have done with histograms. Histograms can use the random method, that is normal, rand, int, integers if you want to, which we have seen before, rand, int, random, rand, rand. Like this we can use here what we have used normal. We had used random normal. So with this we have seen successfully visualization the histogram. Now let's see how to create a pie chart. To create a pie chart, what we need to do? We need to use the function that is pie. Okay. This method is used to plot the pie chart. Okay. Here what I am doing, I am taking only one of the axis, one of the array, that is y-axis. Okay, what I am doing, I am importing Matplotlib pyplot as PLT and import numpy as n. So I am taking in a y-axis what I am doing, np.array 35. I am giving like a 4 values like 35, 25, 25, 50. Okay. Now what I need to do, I need to plot pi, that is y-axis. So let's show the plot. So this is the pie plot. So 35, 25, 25, 50, 35, 25, 25, 50. This is how it goes. This is how it works, right? So what are labels? Before we have seen, we can also create the labels, different types of labels. Okay, label is nothing but a label to the pie chart with the label parameter. We can give the parameter. The label parameter must be an array with one label for each wedge. We can give the each wedge. For each wedge, we can give some of labels. So we can create some of the labels. So what I am doing, I am importing matplotlib.pyplot as PLT, import numpy as np. So y is equal to what I am taking, y is equal to in y-axis I am taking np.array 35, 25, 25, 15. Same values I am taking, but my labels I am assigning for each one, I am assigning one of the labels. Apples, bananas, cherries and dates. Okay. So now what I need to get? Here I had assigned my labels. In labels I had assigned my labels. Labels is equal to my labels. In plt.py, y this is the value what I need to display, and labels is equal to my labels. Whatever we have taken up my labels, that will be shown in the output. plt.show. So this is apples, this is bananas, this is cherries, and this is dates, right? So we can from where we can if you want to start from the particular angle, we can also start with the so as mentioned, the default start angle is at the x-axis, but you can change the start angle by specifying a start angle parameter. The start angle parameter is defined with an angle in degrees. Default angle is 0. So what we are doing, we are importing matplotlib.pyplot as PLT, import numpy as np. Y is equal to, I am taking the y-axis, that is np.array. In that I am taking some of the values. In labels I am taking apples, bananas, cherries and dates. So what I am doing, I am giving the straight start angle from where it should start at 90 degrees. From 90 degrees it should start. So how it will be the output? See, this is the output. From 90 degrees it has started. So we will get like this. Okay, previously how we will get, we didn't assign any of the start angle, so it has started like this. Here we had assigned the angle, so it started like this. So what is explode? Explode is nothing but it allows you to the parameter. If we have specified with something parameter, okay, for with each of the one of the value that is far from the center of the each edge is displayed. Okay, here what I am doing, I am exploding. My explode is equal to, I am giving some of the values. I am giving 4 values. At apples I need to get 0.2, and at bananas I need to get 0. I need to get at cherries I need to get 0. I need to at dates I need to get 0, right? So this is what I am doing here. So plot.plt.py by labels, my labels. What we are doing here? Here labels is equal to my labels, explode is equal to my explode. Plot is equal to show. We need to show the plot, right? So this is how it shows. So at 0.2 at apple we have given 0.2, so it has cutted like this. Okay, this for everywhere if we have given 0.2, what it will do? It will cut it that one also. See, it will cut like this. If we have given at every place, if we have given, everything will be cutted and it will shows like this. So this is how it will shows, right? Okay, if we are mentioned only, if we are showing that highest point, apple is in highest point, so we are showing that it is in cutted method. Okay, so apple is in high size. Like we can show like that also. We can also give the shadows. Like what is shadow? Shadow is nothing but add a shadow to the pie chart by setting the shadows parameter to true. We can also set to true. Shadow is equal to true. If it is showing true, then what will happen? We will apply the shadow. See, we will apply the shadow there. See, this at some point there is showing some of the shadow. For colors, what we will do? You can also set the colors to different like wedges. So here my colors is equal to, for apples I'm giving black color, for bananas I'm giving hot pink, for cherries I'm giving B, for dates I'm giving some of the value. Okay. Plot.py, what I'm giving y, labels is equal to my labels, and colors is equal to my colors. I need to show the plot, right? See, this is the plot. At apples we had got black color, and at bananas we had got pink color. Like this we have got different colors. So if you have used an R, that is nothing but red. If you have used a G, that is green. B for blue, C for cyan, M for magenta, Y for yellow, K for black, and W for white. These are the different types which we are taking. Okay, what is legend? Legend is nothing but to add a list of explanation for each edge using the legend function. We can also list, we can give the explanation for each wedge. How it will be happen? See, for each wedge I am giving here, what is the title I am giving? Title is equal to how many fruits we have taken here? We have taken 4 fruits. Like, see, I am importing matplotlib.pyplot as plt, import numpy as np, and y is equal to empty.array. I am giving different types of arrays. My labels is equal to apples, bananas, cherries, dates. So I am taking y value, and labels is equal to my labels. I am plotting the legend, that is the list of description. What I am giving the title, that is 4 fruits. Plot show. See, for 4 fruits we have given apples, banana. We had given the descriptions with colors, right? Apples, bananas, oranges, and this. This is all about the Matplotlibs. And in another session we will continue about the SkyPy module.